Arduinos. Now these are very inexpensive microcontrollers, and you can do a lot with these. And I've been demonstrating just what you can actually do. So my goal is really to push inexpensive robotics. How far can we take it? How far can we push that boundary of inexpensive robotics, and what can we do with it? So this is an Arduino Mega. This thing costs in the order of $20 to $30. It has a lot of digital input and output pins, probably too many than the average project would need. So there's something like 50 on here, 50 or 60. You only need a couple usually to hook up a few sensors here and there. So what we're learning on today is going to be the Arduino Uno here. Now this is kind of a mid-sized board. It's got less pins, but you still have about 13 to 15 digital pins and about 6 analog pins there. So you still have a lot that you can interact with. And this thing you can get Arduino official product. There's also thousands upon thousands of companies that make clones of these as well and sell them. And so you can get these on average for about $5 to $20 usually these days. There's a lot you can do with that. And then this is my favorite over here is the Arduino Nano. So this actually has a lot of the same functionality as the Uno, in a much smaller package. And I have some demos here set up with them. So this is what I love to use these days, this little Nano here. It still has a lot of input-output pins, enough that you would need in a school to do a project, and it costs about $5. So it's pretty amazing what you can do with this as well. Now I have no affiliation with Arduino at all. I care about just what's the most inexpensive, cheapest microcontrollers you can use that are actually useful, and what can you do with them. So here's other microcontrollers as well. So here's Raspberry Pi. This is a little different. So the Arduino, you actually connect to a computer, you upload your code through the USB port, and then once the code is on the Arduino, it just performs whatever function you tell that microcontroller to do. So you can upload new code, overwrite it, get the microcontroller to do a new function if you did want. This is actually a full little computer here. So Raspberry Pi actually has a built-in little operating system, Debian. It's very neat. You can actually set this up. A lot of people do emulators with this just to demo its functionality. And so this is like a little computer standalone by itself. But this is quickly becoming one of the fastest growing microcontrollers in the world here. This thing is awesome. I've got some demos for you. So this is a WeLost D1 Mini. It's a little microcontroller and it's fully Wi-Fi capable. And so Wi-Fi capable means you can beam your data anywhere you want through your smartphone, to your smartphone. You can build a robot. You can control it through your smartphone if you want. That costs in the order of $3 to $6. So for $3 to $6, you can Wi-Fi beam your data anywhere you want to the internet, to your smartphone. It's pretty amazing what you can do with inexpensive microcontrollers today. Okay. So there are literally hundreds of thousands of sensors you can use. Here are 6 of them. So I just want to keep it simple. So here we have a rangefinder. So this can detect distance here out to about 2 meters effectively. It's ultrasonic, so it sends out a ping. It listens back, and you can get your distance from about 2 centimeters up to 200 centimeters. Costs about $3. This here is a photoresistor, so it actually detects light level, and that's actually the second lesson we're going to try to get you. So we're going to get you actually coding on Arduinos and using them. We've put some Chromebooks. Thank you, Jason Jennings, if he's in there. Okay, thank you from Millwood for providing these Chromebooks. Really appreciate it. So we're going to try to get people actually coding on these, so you have an idea of how to actually use Arduinos. And then we have here a humidity and temperature sensor. So this thing as well costs like $3. If you have an aquarium, for example, you need to carefully monitor the humidity or temperature, you can do it with that little sensor there. Very easy to hook up. A passive infrared motion detector. So if you've walked into a room, the lights automatically come on, and you look up, you will actually see one of these. So it's a little about $2 sensor, it's up in the ceiling. It does not detect specific location, but it detects that there's movement in a room. And so don't worry if you walk in the bathroom and the light comes on. It can't tell where you are, it just knows that there's movement in that room. So these are everywhere. Next room you walk into and the lights come on, just look up. You'll probably see this. Okay, so this is a strain gauge as well. It costs about $1. So you can do a lot of things with this. We'll talk about that later. But you can actually make a scale. I have right here hooked up. I'm not going to show you that in a little bit as well. You can also do a force strain gauge as well. And we have an accelerometer. So this is actually a 3-axis tilt accelerometer. You can put that on a robot or a demo. You can tilt X, Y, Z axis, and you can actually tell, it'll plot out. You get about 9,000 samples per second if you do want, using an Arduino. And you can actually get very precise data readings. You can even calibrate these and go to other levels. And that costs about $3 as well. So this is the world I'm trying to bring to people. It's just inexpensive robotics. Okay. So here we go. So this leads me to a project that I've been working with my friend David over here on. So to demo some of the Wi-Fi capabilities of this little WeMOS. So remember that little about $5 Wi-Fi micro I was telling you about? Well, this is a simple demonstration here. So I 3D printed just a basic little cart. I have a little push button here. So just on-off toggle switch. An LED is going to tell me when it's collecting data and when it's not collecting data. And then it's going to wirelessly beam that data through a Wi-Fi router, which I'm going to set on my phone as a Wi-Fi router. So it's going to beam that data through my phone to a website that my friend David made, and then it's going to plot that data on the web. So hopefully this all works. This is the first live demo of it. Okay? Famous last words, of course.
You have a pre-made kit.
What's that, sir?
Like this morning when you have a pre-done, so that if it doesn't work, it's like,
we did, yeah. So this is actually, I'll show you the website here. Okay. So this is actually a website that you can use that David made for you. And you just send it your data wirelessly, and it'll plot your data. And you're all welcome to use it. So it's dial.phaseshift.text/plot/distance. We can get you that information, so you don't need to remember it just now. So I'm actually setting up my phone right now as a hotspot. So my phone is going to act as the Wi-Fi router for this data transmission here. Okay, so my phone is now a hotspot. Set it up right there. Okay. So all I do is I turn this on, and it's going to connect to my phone. And if this LED starts blinking, we are in business. Okay, so LED is blinking. So it's going to pulse 3 times here. And as David, okay, I'm actually going to stop that. So as David pointed out, I have to clear the data first for my last data set. I saw David over there being like, remember. Okay, so we'll try this again. So it's connecting to my phone. And I set it up so the LED pulses 3 long pulses, 3 short pulses, and then when it goes on, it's collecting data. The LED goes off, it's not collecting data. Okay, so 3 long pulses, 3 short, it's collecting data. I'm going to release it. Okay, so when the LED goes off, it will stop collecting data. There we go. And now it's actually wirelessly sending that data to my smartphone as the router, and then it's beaming it to this website here. So I'm going to refresh the website here. There we go. So it actually works. The first ever live demo. So this is, again, pushing the limits of inexpensive microcontrollers. It's amazing what you could do. I could have sent 9,000 samples a second if I wanted. I just sent, I think, about 3 a second, basically. Just keep it pretty basic. Okay, so that actually worked. Excellent. So I have another demo here with the WeMOS. So this is actually Ted Mancheski in the back there. He actually had there was a little leak somewhere in the basement, and he just wanted a sensor that would just send him an email when there was a leak happening. So this little $5 microcontroller just hooked up a moisture sensor to it, and it's going to send an email here to cap.home@2018. Okay, so I dipped it in some water. Detector, there's a lot of water now. Okay. So it actually takes, so this information is being sent through the Wi-Fi network again. My phone is just a router. You could just have a router in your school, for example. And it is now going to a web page, and I'm going to email. It does take a few minutes to actually work on the web side of things, which is a bit slower than the microcontroller itself. But in about 60 seconds or so, hopefully, an email pops up here with soil moisture reading. Okay. So while that is going, I'll this. Give it one more refresh. Okay, there we go. So it did pop up. Okay, so we got our moisture reading. So I dipped this straight into the water. We're fully flooded at this point. Okay. Excellent. All right. So that's just another Wi-Fi demonstration there. Yeah. All right. Let's go back to our slideshow here. Okay, so we also have a strain gauge that I've set up. So the machine shop helped out. This is just a $1 strain gauge. It can detect up to 10 kilograms as you flex it. So that is what this is right here. And actually, I do need to X out of this again, of course, to bring up Arduino. Okay, so we're going to view in the serial plotter here. So this is Arduino. For your information, this is what the Arduino environment usually looks like. And so this is using that little $1 strain gauge sensor. I'm just going to do a very simple demo, prove that it works. So I added some weight on top of it. But you could as well use this as a force sensor. You could bounce the ball on it. You could do tons of experiments with this little $1 sensor, basically. Something else you can have fun with as well. So these are actually servos here. So a 180-degree rotation servo. It rotates. It doesn't do a full 360, but it can go, 90 degrees to the left and 90 degrees to the right. And there's a lot you can actually do with that. And I'll show you a video next of what you can do with that. There's also a 360-degree rotation servo. These make great wheels on cars. So if you want a little obstacle avoidance car, you can get these. These are on the order of $3. It's on the order of $8. Still within the budget quite often. So I'll show you one of the first little projects I did here. This is actually using the 180-degree rotation servos. And in total, this cost about $20. This whole robot built with popsicle sticks. It's a little two-leg blocking robot, basically. So it's just, I built controls into the keyboard, so as I press buttons, it does certain actions, basically. Okay, so that is an example. Now, of course, you'll see in a second my cat jumps up. My cat actually did knock this on the floor and break it, so I don't have it anymore, unfortunately. But that is the issue when you're building with popsicle sticks, I must say. So a lot of the robots now are not built with popsicle sticks that I do, yeah. Okay, we're good.
We gotta feed a cat. Yeah.
That's true. Okay, I'll wait till the cat. So later that day, he got a little closer and kind of knocked it over a bit. But that's okay. I love my cat. He's an awesome cat. Okay, you're good. So you can also control motors as well. So these are high RPM motors. You can control slower stepper motors if you wanted. These would be for like little airplanes if you did want to build that. You have solar cells, so you can build all these little robots, and because they use so little power, you can actually power them if you set up a solar cell grid as well. So just something for your knowledge. And now this is what I really want to talk about. I think Stephanie knows, yeah. So these are relays. So as it turns out, I can use a $5 microcontroller. You can too, and you can control almost anything with that if you use a relay. So you send the relay a 5-volt signal, and then the relay allows a huge amount of current to flow for whatever application you need on the other side. So these are just 2 amp relays, but you can get 10 amp if you need, you can get 20 amp, you can get whatever amperage you need relays. So literally, I can use this little controller here to control all the lights in this room if I wanted, to control a huge rotary stage, which we've actually done back in the department as well. But I have a few basic demos here, and then we're going to get you actually coding with the Arduinos. So what I've done is just an Arduino Nano here, and I have a relay. And so the microcontroller is actually going to control this lamp right here. And I'm going to power that Arduino Nano just with a 9-volt battery. So this isn't connected to a computer. I've already uploaded the code onto the Nano. And I'm just going to activate that code by giving it power here. Okay, there we go. So the lamp is controlled by a $5 microcontroller now, getting power out of the outlet, but using the relay as the switch. So I'm sending a 5-volt signal to the relay, just turning the relay on or off, basically. Okay, so it's blinking away on off every second. It's going to pause, it's going to wait for 20 seconds, and then it's going to start blinking SOS in Morse code. So that is actually the first lesson that you'll be doing today. So you'll be hooking up LEDs, but I want to make the point that if you just add a relay, you could just as easily be controlling your lights in your home. If you did one for like $10. So it's pretty inexpensive, everyone can usually afford that. So there it goes, it's blinking SOS, so 3 shorts, 3 longs, 3 shorts here. Okay, so that's the first demo. Now there's one more, and then we're going to get you actually coding on these things here. All right, move this out of the way. Okay, so this one is a little more complex in the sense that I've added one extra sensor to it. So I have just a distance sensor here. This is that ultrasonic rangefinder. All it does is detect distance out to about 2 meters. So this fan is hooked up here. I'm going to do the same thing. So I've got an Arduino Nano, the code's already on it. And now the way it's coded is if someone walks in front of this sensor here, the fan will go on. So it's very basic code. So I'm going to try to demo that now. So I walk in front of the fan goes on, I walk away from the fan, and the fan hopefully goes off, and it does go off. Yeah. Okay. So that's another example of what you can actually do. So the point I want to make is today we're hooking up inexpensive little LEDs and things like that. But with the relays, you can literally hook up anything pretty much that you wanted to control, big things that you want to control. Okay. So we are now going to begin the workshop